All right, this video is about using the normal distribution. So when we're talking about the normal distribution table, we have both a table and a graph. Well, the numbers inside here, these numbers are all probabilities. Each one of these decimals inside here is giving you the area under the curve. So that's the connection between these numbers and the graph. So each table entry is an area under the curve here. The table is always telling you the area to the left of Z. So it's always to the left. The total area under the curve, the whole thing, is 1. That's why oftentimes in problems we'll have to subtract from 1 in order to get the answers. Now, we have the z-scores. We have the z-score, we know a formula to find the z-score. We know that the z-score is equal to the number, the x value minus the mean divided by the standard deviation. We can read the z-scores off the table by looking at the numbers on the x and y axis here to find the z-scores. And the z-scores are like the numbers on the x-axis on the graph. So we can see the z-scores on both the graph, the table, and from the equation. So the standard deviation is how far the z is from the mean. And we can see, we know from the table that we have both positive and negative sections of a table. So the negative values on the table are telling you the ones to the left of mean, and then the ones to the right of the mean are positive. So for the normal distribution shown above, find the probability that an observation falls in the shaded region. Okay, so they ask for the shaded region to the right, but we know that the table is only going to give us values to the left. So I can draw a picture of this by having my standard normal deviation curve here, and I'm finding the value for 1.15. I'm going to use the table to find the value, but then after I find the value, because the table is only going to give me the left side, I'm going to have to subtract from 1 to find the other side. So looking at my table, I can look up 1.15 by coming to 1.1 and then over to the 5. And I can see that z of 1.15 gives 0.8749. All right, so that is the number that is on the left side of the curve over here. What they've asked me for is on the right side. So what I need to do is subtract from 1. 1 minus that score gives me my answer. So the probability that it's in the shaded region is this number right here, 0.1251. Okay, and that's the number on this side. The probability of the shaded region is 12.51%. Great. For the normal distribution, verify that the probability rounded to 2 decimal places is within 1.85 standard deviations of the mean is equal to 94%. All right, so let's see if we can do this. Let's start with a picture, and they're asking us about finding the values 1.85 standard deviations from the mean. So here's the mean. We're trying to find the values in between these two lines. So first we can look up 1.85 on our table, and that gives 0.9678. So that is the area to the left of the positive line. Now if I look up the negative value on the table, okay, I have another number, much smaller number. That is the area to the left of the negative number. We want to find the area in between them. So we need to subtract the 2, and when we subtract the 2, what we'll have left is the area just in between. That's this part right here. And we can round that to 0.94%. Okay, let's see if we can sketch different cases on the same graph. Well, if they were asking us to sketch different cases, 3 different cases on the same graph, each case is going to have a different z value that means it's going to give different standard deviations, different widths around the mean. So this one's wide, okay? We could also have a narrower one and a narrower one still. So if we were to graph all different ones on top of each other, we can see that the graph looks something like this. Okay, that's just an interesting point there. Okay, so let's see if we can find the z-score for which a total probability of 0.89 falls more than z standard deviations in either direction from the mean. So we're going to start by drawing a diagram. Okay, and what they're asking us to do is find z. So the thing we're trying to find is the number down here on the x-axis. Those are the numbers on the outside of the table. Now the part that's shaded here, one more. This is the part that is 0.89. They're telling us that 0.89 falls more than z standard deviations in either direction. So these two pieces on the side are what is 0.89. If we divide 0.89 in half, we can find how much is on either side of the z. So when we divide 0.89 in half, we can see that each half here is 0.445. Now, the area to the left of positive z, this section right here, to the left of positive z over here, is all of the sections except for the one. So if we subtract this one section out, we can get our answer. We want to find the area of just of this section here. So if we do 1 minus, we get 0.555. That's this area here. Now we could have also found that same number by finding the amount in the middle section, right? We could have subtracted it from 1 and found 0.11. That would have been the number in the middle. Then we could have added these two sections together to get the 0.555. So either way is fine. But now, in order to get the answer, remember what we're looking for is the z down here. We need to look on the table and see where we see this 0.55 on the table. We need to find the z-score that gives 0.555 on the table. So we look at the table, and when you look at the table, the first number here that has 0.555 is this here, and that is a 1, 0.1, and 4. So it's found at 0.14. So that means that a z-score of 0.14 has an 89% probability from the mean. Great. A health study reported that in one country, the systolic blood pressure readings have a mean of 125 and a standard deviation of 19. A reading of 140 is considered to be high blood pressure. What is the z-score for a blood pressure reading of 140? Well, I can just plug into the formula for z-score. Okay, and when I plug into the formula, they've already given me the value I need, the value they want me to find, the mean and the standard deviation, so I can just plug in and find that the z-score is 0.79. If systolic blood pressure in that country has a normal distribution, what probability of population suffers from high blood pressure? Well, in order to do that, I just need to look up my number in the table to see what the actual probability, what the percentage is. Okay, so I look on the table at 7.9, and I can see that the percentage below 7.9 is 0.7852. That's the percentage below, but they're asking me for high blood pressure, which is above. So I need to do 1 minus it, and I get my answer. What proportion of the population has systolic blood pressure in the range from 95 to 140? Well, we already did half the work here because they're asking us about the 140. And we already found that for x equals 140, we have our z-score, and we were able to read the number off the table that goes with that. So we already know that for 0.79, we found this area. Okay, so now let's do the same thing for 95. If we do this for x equals 95, we get a z-score for 0.95, and we can read our number for that off of the table, which is 0.0571. So to get our answer, we subtract these, and subtracting them gives 0.7281. And let's do one more. Let's see if we can find the 90th percentile of the blood pressure readings. Okay. Well, asking for the 90th percentile means that they want to find the x value that you could plug in to get z that would give you the z value that's closest to 0.90 on the table. So we need to work backwards. We know the 90% on the table. We have to work backwards until we can get back to x. So let's start by looking at our table and finding the value that is closest to 0.9. Now the first number on here that has 0.9 is the z-score of 1.29. Okay, but actually as I was looking at this, 0.129 is actually not the closest to 90%. This number is actually closest to 90. Okay, this one is actually closer, even closer than that one. So we're going to use z to be 1.28. So we plug into the formula. Okay, we already know our z. We don't know our x, but we know our mean and our standard deviation. So when we plug into the formula, we're able to solve for x here now. So to solve for x, we simply need to multiply both sides by 19, then subtract, then add, that should say add, then we're going to add 125 to the other side, and we're going to get for our answer that x is 149. So that means that a blood pressure reading of 149 is in the 90th percentile of the data. Great. So, great job. You're awesome.